Okay, thank you very much. You are welcome again. In this episode, we are going to look at how we can relate pressure and volume for an adiabatic process. Now, in this particular derivation, you needed to have actually seen how we derived the relationship that is linking temperature and volume. So that this one becomes very simple because I will not go back to derive the relationship between temperature and volume. I'll use it here and then we can connect and see how we can get the relationship between pressure and volume. So in that previous episode, we actually derived that we know that T V gamma minus 1 is equal to a constant. This is what we derived, or this is the relationship that is linking temperature and volume. So from this, we can connect and get the relationship that is linking pressure and volume. So from PV equal to a constant, which is nRT. This is an ideal gas equation. So in this case, for 1 mole, we shall have N is equal to 1. So this implies that PV equal to R what? RT. In this case, what we want is the relationship between pressure and volume. So pressure, pressure and volume. But the T, we don't have it. So I have to see a way of replacing this T from this equation. And then I bring the aspect of pressure inside. So that can only be done by making T the subject from here, and we come and replace it here. So this is going to be, therefore we shall have, this is going to be P V over R is equal to T when you make T the subject here. So I'm going to replace for T back here. So therefore I will have that PV over R times V raised to power gamma minus 1 is equal to a constant. Yes, so I can multiply both sides by R, and then I will have PV equal to, PV times V to power gamma minus 1 is equal to R times a constant. And remember, R is the molar gas constant times another constant. It will actually give us a constant. So when I have this P, so I will have this V. When you indices multiplying the same base, then you have to add the power. So I will have the power of this one is 1 plus gamma minus 1. This is going to be equal to a constant. And so in this case, we shall have that PV. This and this will go. I remain with only gamma is equal to a constant. So this is ideally the relationship that is linking pressure and volume for an adiabatic process. So therefore, we can write this as P1, V1 to power gamma is equal to P2, V2 to power gamma. So this is what, or you can have it equal to P3, V3 to power gamma. So you have to know the relationship that is linking temperature and volume, and the relationship linking pressure and volume for an adiabatic process. These equations are really very important when you are carrying out some dynamic calculations. Thank you very much. Thanks for following. Please, if you have not yet subscribed, please subscribe. Hit the like button, comment, and we move on. Thank you very much.